Howdy everyone, and welcome to the graphing tutorial for CHEM-106. In this we're going to continue where we left off for the CHEM-105 tutorial, taking a look at how do we take larger sets of data where if we have to do more manipulations to it to get our graph ready, how do we use that with Excel to do the work for us to make sure things are correct, everything's lined up, and then get a good graph for our reports. And so we've got some sample data already set here. This data comes from the heat of vaporization lab. That's usually experiment number 2 for the semester. So you will get to something that's very much like this very quickly. So if you need to come back to this tutorial during that time, it might not be a bad idea. But we're going to take this data, we're going to manipulate it, we're going to get 3 or 4 additional columns from calculations, and then we'll make the graph like we're supposed to. So we've got temperature here in Kelvin, we've got some volume of air and water in milliliters, and then we've got 2 extra numbers down here. We've got an atmospheric pressure, would have been measured in the lab and converted to ATM, and then gave a little shortcut here, gave you moles of just dry air in our sample. When you do this lab, you'll have to get that number yourself from additional calculations, but we'll just take it as given right here. And we're going to use these 4 things to come up with what do we need for our graph. So there's 4 things we need. I think it's 4 things, maybe a little more. First off, we need our volumes to be in liters. So I'm just going to go ahead and make these titles ahead of time. So volume in liters. We are also going to need, let's get our labels right. That's volume of air and water. And then we'll adjust our columns so that we're not cutting things off. Then we're going to need, based on the total pressure, the moles, and that volume, we're going to get the pressure of just the air, not the air and water, so I guess I should say dry air, and that's going to be an ATM. From that, we'll then be able to get the pressure of just the water, also an ATM. And then finally from that, we'll be able to get the natural log of the pressure of water. All logarithms, they get rid of units. So if you have a log base 10, log base e, natural log here, whatever that is, it's just the number. And then the final thing we actually need the temperature to be in 1 over temperature for our graph. So we'll just do 1 over temp, which will be 1 over Kelvin for our units. All right. And so now those are the data comes. So it's 5 things we need it. But we're going to go through how do we set these up in Excel so that it will do the math for us. And then we'll say, okay, now once we've got our data, let's go back through, do the graph, make sure we have all our things properly so it's a good graph. So the first one here, we want to go from milliliters to liters. That's just a simple metric conversion. And so the most basic type of formula for Excel is just to go ahead and hit equals. That tells Excel we're going to do a math problem. You're going to calculate something when you start with equals. In this case, we want to do this milliliter volume, divide it by 1,000. So I'll click on this one, cell B2. I'll then hit the divide sign and divide by 1,000. And when I hit enter, it goes ahead and did it for me. There's 0.0098. Now instead of having to do that in your calculator over and over again, you just then move your mouse to this bottom right corner. You see there's a little green square there. When I move the mouse over it, the plus sign changes from the big white plus sign to a slightly smaller black plus sign. I click and drag that down. That tells Excel whatever I did in that first cell, do the same thing to the cells below it, but also keep it lined up. So if we click here, notice it says, oh, it's B3 divided by 1,000. And then this one is B4 divided by 1,000. So, oh, right there, divided by 1,000. B5, B6. So it took that, when we drug it down, the cell down, it said, oh, look at the cell going down, divide all of them by 1,000 as well. So if you have a simple conversion like that, that's a really easy way of saying, I don't need to punch this into my calculator over and over and over. I can just let Excel do it. All right. Now to get the pressure of the dry air. In this case, actually I should go back. One good thing to do when you're doing Excel calculations is to indicate what was the math that you did. so that you could get it. So if in this case, don't start with equals, because Excel will say, where's the math? I'm just going to type in B number to say, oh, it was my B cell divided by 1,000. That way I can say, oh, that's how this column was calculated. I took the B cell, I divided it by 1,000. All right. Now for pressure of dry air. For this one, we want to use the ideal gas law, that the pressure times the volume equals the moles times the gas constant times the temperature in Kelvin. But we want pressure, so I'll do this one. This will be P divided or equals nRT over V. You say, okay, well, where did that come from? Well, my pressure is what I'm solving for. The moles are coming here from the moles of dry air. R is the gas constant, so okay, that's there. Temperature is going to come here from the A column. I got my Kelvin temperatures, and my volume is now coming from here. And so you see, oh yeah, the temperature and the volume, they're lined up. If I drag this down, once I type in the equation, they'll go together, right? A3 with C3, A4 with C4, they'll all be together. But I need to keep this moles the same for all of them. That moles doesn't change. It's a constant. So how do I tell the equation, keep that number the same? Because if it tries to go below it, there's no number there. So to do that, we use a special symbol. We use the dollar signs. And so this is cell B15. So instead of clicking, it's easier to type in $B. That tells it stay in the B column. $15. That means, hey, stay in cell B15. Do not go anywhere. It doesn't move. So it's just cell B15 and then times, times the gas constant. So 0.08206. And then times the temperature. Oh, that's cell A2. And then divide it by the volume. So that'll be divided by C2. If we hit enter, okay, we get a number, 0.7209, and then keep going. Now watch, if we drag it down, we get different numbers, so that's good. But let's look in here. This one says, oh, now it's B15 times the gas constant times A3 over C3. Okay, yeah, that's right. Now it's times A4 over C4, A5 over C5. But notice the B15 stays the same because those dollar signs said lock it to B15. All right, so you had to do it in front of the B and the 15, but that's how we tell it use this as a constant. That number stays the same each time. I guess we could have also typed in the number, but sometimes it's helpful if you have multiple ones. You can tell it pick it this one for this one and that one for that one. All right. Now for the pressure of the water, we're going to do a similar thing, because from Dalton's law we know that the pressure of the dry air and the pressure of the water must add up to the total pressure. So that means for this one, it's going to be the 0.9954 minus, and it'll be minus the air column, so we'll say D number. So that's our equation for that one. So that's what we'll type in. Again, we want to use this number the entire time. So that's A15. So this is equal $A, $15. Did not hit dollar sign there. $15 minus the dry air number. And so we get that. We can check 0.72, 0.27. Yep, that adds up to 0.99. Now we click here, we click and we drag from the corner, and we get all these different numbers. If we just spot check, this is cell 9, and we see the equation A15 minus D9. So yeah, that's working out right. Everything's still lined up. We get our numbers here. They're all good. All right, now for natural log. So for this one, it's just going to be, well, natural log of, what is that? The E column, so E number. Just so we know, okay, where did we get it from? So equals ln, and you see there's the function, which is what we want. So you can click on it or you just, leave it there, but ln parentheses, and then our E2. Hit enter, and we get negative 1.29. That looks correct to me, because any number less than 1 is going to give you a negative natural log, so that checks out. Again, we click and drag, and so we keep getting negative numbers. Here, this is column 7, and yeah, it's the natural log of E7. Everything's good. All right, so those numbers will all look good. And finally, we have our 1 over temperature. So this is just going to be 1 divided by my A column for temperature. And so equals 1 divided by A2. You could also type in A2, but I like to click sometimes. All right, and there we go. And yeah, for 335, we should get a very small number. That makes sense. When we take the reciprocal, click and drag, and here's A11, and there it says 1 over A11. So yep, everything's good there. So you see a little bit of extra data manipulation. We get lots of numbers without having to use our calculator once. We let the Excel program do that for us, and we just kind of double check as we go, make sure everything seems reasonable. Now for our graph, we want to follow the same rules as before about scale and labels and everything, so that a reader who didn't do the lab and doesn't necessarily know what you did will be able to get enough context from it to say, okay, I see what data are being plotted, I see the relationship that's being shown, I understand, at least to a good extent, what's going on here. So we want to go ahead and insert a scatter plot here under chart, so just the data points. Let's go ahead and move that so we can see everything. We will right click, tell it to select data. We can also do that up here at the top menu. We'll want to add in a series. All right. For this lab, the X value is the 1 over temperature, so I'm going to click and drag all of those. If you also learn it, you can do this, sheet 1, G2 to G11, but click and drag seems much easier to me. For the Y values, remember to leave that equal sign in there. For here, we want the natural log of the water pressure, so we click and drag there. And you see we get this nice downward slope. All right, and that seems good. You can hit OK, hit OK. So there's our graph. Now you say, hey, wait a minute, it's going, why is the axis up here? Well, because it's a negative, all the values are negative, it puts 0 at the top, and that's fine. But we can make some changes there. So let's go ahead and go through our normal process of making sure things are good. We have a chart title. We want to say that this is the relationship between the natural log of the pressure of water and temperature. We want to say, okay, we definitely need axis labels here, so we'll go to Add Chart Element. You could also right-click over here and use some templates, but we need axis titles for the horizontal. We need an axis title for the vertical. All right, so for the vertical, let's delete all this. This is natural log of the pressure of water. For the x-axis, this is 1 over the temperature, given in units of 1 over Kelvin. You could also do Kelvin to the negative first, whichever way. So that's good. So we've got those. If we say, hey, I don't like these numbers here, I want them down at the bottom, we say, okay, the bottom is negative 2.5. So we go ahead and right-click and format the axis. And we tell it, where does the, let's see, it should be, where does the X hit? Maybe labels, tick marks. Where is this hiding at? Oh, here it is. Horizontal axis crosses, and we'll tell it to cross at negative 2.5. There we go, and so now it popped down at the bottom where we're used to seeing it. We will now tell it we want to add in a trend line. In this lab, you'll be getting the slope of this line in order to figure out some information. And in most graphs we'll have a linear trend line. So again, for that, you can either right-click on a data point and tell it to add trend line, or we go back here to chart, add an element, and add a trend line. You always want it to be a linear trend line. And if we need to format that, Where would right click, format trend line. You always want to display the equation on chart and display the R squared. So for this one, and then we always move it to where it's kind of out of the way. So we get this slope of -5,000, okay. R squared of 0.979, not the greatest, but it's not terrible. But that's there. And then that graph should be good for what we would need in this lab. We've got our axis labels. We've got our axis label here with units. We've got a nice title. There's only one set of data, so we don't need to worry about a key or legend that says which data is which. If you do have multiple trials that you graph on the same plot, which will happen in this course, then make sure you say, oh, blue circles are this one, and red squares are this, and yellow triangle, whatever. Have a little label. But we can see our equation there, so that when we report that for our results, we can say, okay, here's the slope, and then here's what we can do with the slope to get the values that we want. But that's how you'll do graphs here in 106. Just make sure you can handle Excel, and then once you have your 2 columns you need, get them into the graph, proper labels and units, proper title, proper trend line. All right, I hope this was helpful. If you have questions, talk to your instructor. You can come find me during office hours, talk to the tutors in the tutoring center, but make sure you get help working with graphs. They're very important to communicate your results. All right, have a wonderful semester. Best of luck.